Hello, 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 folks. Starting a little late, but that's alright. Oh, stream is not loading. Oh, that's great. Well, definitely not leaderboarding this one. Why is the stream not working? There it comes. Nope, not screen 2, screen 1. There we go. Okay. Got that working. Again, a little late, real life stuff, but here we go. Advent of Code Day 10, only a minute late. Oh goodness, it's some stupid simulator again. So we have small program with instructions. Do do do. There we go. Ah, tough one. So we have adds 2 cycles, registers. Oh, geez, this is the tough one, folks. This is where everyone drops off now. Doing no op. First cycle, X is no op, does nothing. X is still 1. Okay, so we have value in an X. Oh, hold on, it's add X. Okay, I see it is. So let X equals 1 for const instruction of data dot trim dot split by the new lines. Then for every new line, we're going to const command args equal instruction split. If command is no op, continue. Otherwise, wow, thank you, Copilot. Add to X. At the start of the second cycle, during the second cycle, X is 1. During the third, X is still 1. After the third, add X3 finishes, setting X to 4. The start of the fourth, add X begins. During the fourth, during the fifth. Okay, so each one takes a thing going on. Cycle number multiplied by the value of X during the 20 and every 40 after it. Oh, wow, big one. Okay, so we gotta run for the big one. This is a toughie, alright. So I guess we're running on the big input, not small input. Lots of scrolling. Now the cycle logic I have not implemented correctly. Start at first cycle. So I guess we'll say let cycle equals 1. The start of first, no op begins. During first, X is 1. After first, no op finishes. Start of second. During the third, after the third. So during the second, add X begins. So every operation takes during the third, after the third. Interesting. Takes 2 cycles to complete. Got it. Okay. Let commands, it kind of needs to be queued up. If add X commands dot push, it's gonna be or I, which is 2, and then X change is parse int. Then for every cycle, we iterate one thing. I guess all these move the cycles forward. Ah, that's right. We don't. Are these asynchronous or synchronous? Takes 2 cycles. Okay, I see how this works. If no op, cycle plus plus, cycle plus equal 2, like that. Then it's return cycle times X. Big number. So already not succeeding. 4097 to 13140. Okay. Ah, it's only the 20th. So 20 and every 40 after. In the middle of the second add X1. Well, that's great. And so every time I update this cycle, then I check. Gotcha. So it's cycle plus plus, and then after cycle plus plus. Great. So this will be const strength. There we go. Inc cycle. This is a cute little function that will do the cycle incrementing for me. Like so, and then we'll say, hey, if cycle percentage 20 triple equals 0, push the strengths. There we go. Push the cycle times this. Then we do this right down here. I see why the cycle division was important. That's 20 plus 40 after it. Is there a math way to do this? Probably not. Let attempt equals 20 while attempt less than cycle. Attempt plus equal 40 if attempt, so modulo attempt, push it and break. 4097 is not correct. After we return these strengths sums, reduce, sum them together. Don't do that. So now it's too many. Strength, this is a number array. There we go. And now we gotta see, so modulo 20. It's not modulo 20, it's triple equals 20. Still too many, though getting closer. This thing is also happening while attempt less than or equal to cycle, I guess. And this one can be a return. Still too many. Way too many. Sorry, brain running slow. A little distracted. Great, so I have to basically check every cycle what we're adding. X has 10, 60 times 19. Right, okay, so I basically have to see what we're pushing in. Cycle X, there we go, 60, 100, 120, 140, 180, 220, 240. Interesting. If cycle equals 240, break. Nope, that didn't do the math off. Okay, so let's output cycle X. Yeah, 20, 21, 60, 19, 118, 140, 140, what? 118, 108. Get up here. There we go. 118, 120. 120? Oh, my signal math is wrong. During the 20th and every 40 cycles after. That's 60, 100, 120. Oh, if cycle triple equals attempt. Did it again. I done goofed again. That's alright. Great. Oh, wow. Tied that was. Not expected. Great. Seems controls horizontal position of sprite. 3 pixel wide sprite. For blah, blah, blah. CRT draws a single pixel each cycle. Be careful timing. Great. This is terrifying. Render the image given on your program. What 8 capital letters appear? Awesome. So let's go with my example. The screen produces pixels. Okay. What 8 capital letters? Wait a minute. allowing the program to run to completion. I don't see letters here. That's terrifying. I guess it's just gonna have to work or whatever. Let's bring in my real code. Or my sample again. So we got that one. Part 1 in the bag. Boo, 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 boo. It's gonna be tough to visualize. But we will try. It's actually going to be a console log to visualize. There we go. Yep, we don't see that anymore. Get on your own line. Format. And now for part 2, which of course is mostly part 1, but with pixel drawing logic. Gonna be real fun. Let's clean up this for Quokka. Come here, you. Okay. It seems controls horizontal position of a sprite. X is horizontal of the middle of sprite. Count 40 and 60. Draws the top row left to right. Okay, great. 0 to 39. We got wrap over. Draws a single pixel every cycle as a pound. Okay, I understand that. Determine whether visible. Okay. If the sprite is positioned, 1 is being drawn. A lit pixel, otherwise not. Okay. Cycle 1 during cycle draws pixel at 0. During cycle 2, pixel 1. Drawing position 2. Interesting. I just see it going left and right. Now what increments the row, though? Taffy one. Single pixel every cycle. Oh, is the cycle determining? Oh, the cycle determines where it is, and the sprite position determines... Not seeing that one yet. Try to read it again. Draws a single pixel every cycle, representing each pixel. Determine whether the sprite is visible the instant each pixel is drawn. If positioned one of its 3 pixels, okay, great. So this basically, wherever it's at, and a flash of laser is going to be hitting that position. It's a little painful. Let's get this working. Let drawings pixels is an array. We're just going to use an array. So start cycle 1, during cycle 1, CRT draws at 0. Draws the dot. There we go. And X is its horizontal position. Gotcha. So where during the ink cycle, start cycle 1, during cycle 1. I mean, I guess it's going to be right here. So if horizontal is going to be the wrap over. So let's math this out. 40 modulo, or really, we have 39 modulo 40, and then once we get to 40, we wrap back over to 0. 40 wide, 6 high. 0 to 40 is technically 39, so I probably want a 39 wrap. And it's also 1 indexed, so probably 40 wrap is what we want. Yeah, okay, so let drawing X equals cycle modulo 40. Then position 0. Okay, this is going to be off by 1, but I think we can figure that part out. Oof. Pain. Maybe I should actually build the grid. Then it'll be easier to tell when I am exactly off. Or maybe I'll just print it out. We don't need a grid. We can just literally console it out. Okay, so cycle is there. Sorry. So it's the beginning of every rendering that we do this. So before the incrementing of cycle, it's going to be basically the logic for determining if it's being drawn, right? That is determining if it is within the 3. So that is if within the if the 0 middle is within a 3 of distance. So math abs, that's going to be x minus the cycle horizontal persistent. So constantly horizontal equals not this math, but it's got to be cycle modulo 40. I mean, hey, if it's all off by 1, then it's not wrong. Nope, not choice to RPS. Cycle horizontal. We want 0, 1, or 2. Well, technically we want 0, 1. We don't want 2. So if it's less than 2, come on, symbols. Then we want to console process ST out. Oh, look, a pixel. Thank you. We love that. Let's turn Quokka off. Stop that confusion. Ah, don't, whatever the heck you just did. Quokka, stop. There you go. Otherwise, we're drawing the other thing. This could have been a ternary, but we're here now. Dots, I guess, is the symbol. And whenever we are a 40th cycle, if C4 equals 0, I guess. Right, that should be console log or whatever. Oh, not in the right terminal, of course. Let's start a little late. CS solutions. Nope, CS 2022 solutions. Big double digits. Solve. Please give cool ask. This is the one time it's like the visualization is part of the problem. Oh no. PLPAF. Oh, this might be my answer. PLP. Wait a minute. Oh, look, I have the actual example above. It does appear to be matching. PLP, AFB, CL. I assume that's my left half of the P, just off by 1. A 590. Whew. Tough one. A intelligence and intelligence. Appreciate you both coming on by. Oh, that was a tough one. All disheveled coming in here, but hey, we actually got pretty well on it. Where's the thing? It's the wrong thing. First one where the visualization was part of the problem. Yeah, sub 1,000 on both. Actually, pretty good for the number 2. Yeah, we burned through that one. I mean, it's thing is wrong. Maybe it needs to be 39. 39. I think it's good. We didn't draw the thing first. Maybe my index is literally off. Well, that's not it. Cycle needs to start at 0. That's probably what's up. Quick math. Oh, hey, no, that's not it. Interesting. Yeah, it's not the worst bug. Let me actually use the pound sign so I can compare to the original. Yeah, so we have 1 on the left, where they have 2 on the left. Yeah, I don't know how I did that wrap around, but probably if we do it down here, maybe that's what's up. Oh no, that ain't it. Okay, this is as close as we're gonna get for the commit at least. Day 10. TypeScript solution. Don't delete that file. Here we go. Yeah, I guess first is figuring out this lovely little bug. Lovely, lovely little bug in a rug. Lap ass blue. So it is outputting all the correct things. So this one's the last one. Maybe if we made this all asynchronous, my brain could follow. Shave the brain. Yeah, that should be good enough. Be gone. And we don't want double rendering, so let's do the first. So the second one's cooler. Just do the second one. Though the first one's easier to follow. Too late though. Okay, let's give this a run, and then in here, promise delay for 10 milliseconds. Should do the trick. Might need to crank it to a hundo. Huh, that was something else. Oh, this console log showing up now. In my way. Yeah, we're not supposed to console log this output. At least with this brute way of doing it. Was that it? Nope, that was not it. Huh. This looks awfully pretty, though. Despite it being wrong. What an interesting off by one. So start cycle 1, begin executing. During cycle 1, draw. During cycle 2, draw. Finish executing 15. There's 2 draws. Wait, 1, 2, 3, 4, 5, 6. How you got that right? Yeah, so cycle 1 starts off. We start that. We don't execute it. So yeah, cycle 1. We start it right here. We draw the pixel in position. Then cycle 2 starts right here. We draw a pixel in 1. Then 15 finishes. No, go back. Ah. Control Z the way. Because it's during the finish that it happens. I think this might be it. Huh. Well, now this delay isn't actually helping me. Don't look right, though. A very fun timing problem. Heck no, though there are some shapes in there. Not the shapes we're looking for. I mean, it was enough for us to get a solution, though, right? And that's all that really counts. Begin executing 15. Draw at position 0. We do the draw. Then start cycle 2. During cycle 1. It's just a weird off by 1, whatever it is. It's the weird thing that it's at the end. Maybe that indicates a math problem. Did I math it up? Might have mathed it up. Okay, yeah. Cycle starts at 0. Maybe I should keep track of all the cycles at, or the values at the cycles. I think keeping track of all the values would make it easier. Because then I could pull out the correct value at the correct time instead of dealing with the math, which I think is throwing it off. I don't know. Yeah, well, I do the drawing before the increment. That is correct. My x value is here, initialized at 1. Interesting. Yeah, my brain can't figure out what's going on here, so we're gonna brute all the values. Const x's equals, congratulations, you're an array now. What we're gonna do is through this generation, instead of adding it to every time, we're just going to push to the actual thing. So x's dot push x. Well, technically it's x's the last value. There we go, and that's not. Be happy. The cycle movement, we're not gonna do that here. We'll do that later. Yeah, no moving the cycle, because this is just part 2. We don't need the rest of that. X's dot push, x's dot at -1 plus the change. There we go. Be cool TypeScript. This is a lovely array. Well, you already know it's an array of numbers. Be cool. Drop that. Drop the pixels. Drop the increment. All the way back down to simple math. Because the scheduling is where I have gone wrong. So we have all the values. We now want to go through each value, and because every value corresponds to a drawing. Yeah, loop through the values. For that's not wrong. It's not 20. It is x's dot length. For every x, there is a cycle. Now, whatever that x value is, I've already properly calculated. Well, I guess this is what I want to use. There you go. Not the rest of it, though. So x value, if x is less than 2, right? And do I have the 40? I don't have the 40. I deleted that. Oh, of course, 0. There we go, which is my 40 overroll. No! My x's ain't have enough. Oh, cycle 1, I believe, first of all. I'm using, no, cycle 0, yeah. Oh, yes, we're not doing this anymore either. Yeah, let's console log all of our x's. Wow, here. This might be a lot. Yeah, it's a lot of numbers. That was a bad idea. Doodaloo to that. Yeah, no op. And that initialized with a 1. Drop these two variables. Variables. Cycle starts at 0. We pull out the X. Okay, let's see what this is here. Console log X minus core, X core, and then this number, which means no outputting for this run. There we go. Lots of outputs. Let's find the one we care about. There we go. 1, 0, 1, -1. Right, all those absolute away. So this is pixel, 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 no pixel. And if I were to go back and output this, so that's 1, 2, 3, blank, 1, 2. That is correctly happening. Ah, that thing's happening there. Dang it, where'd you scroll to? First, I got a console log going way too fast. If, I suppose if modulo 40, because this is saying if it's 0, but I don't care if it's 0. Oh, no, that's not what I wanted. I guess this is technically after. Or is it before? Maybe it's before. Still rendering like everything's wrong. But this change pushing this before might have been the issue. Time traveler. Select all, copy, drop, and time travel. There we go. Put that back. Move that console to before the party. Well, we'll go and move you up there. See if that makes it look a little prettier. Oh, that is... Huh. Off by 1 character. Okay, we're even closer now. Now we literally are off by 1. Ink cycle needs to go from 0 to 1, doesn't it? So here, and then we say increment cycle. Nope. I mean, yes, actually that is a yes. It just dropped that one off. Okay, so if cycle, if it's not 0, and you're divisible by 40, you're on an edge. Oh, this looks like it. I got extra line down there, but that's okay. So now we need to run it on this one, because this is one we actually have an output for. Okay, boop, which means we drop out that one and see if this looks correct. Okay, got that console in there. That's not helping no one. Goodbye. Once more. And once we fix this, then we can start our refactor. Look at that. 2, 2, 2, 2. It's basically literally 2s. I didn't realize that. The bottom one is 1, 2, 3, 4, 5, 6, 7. Oh, it's 7s. 7s. Hey, we got the visualization working. Well, we can get to clean all this up. So part 1 and part 2 can be completed in the same thing, basically. Function. So what is the lore behind this? Simulate CRT data string. We're gonna return 2 things: a string and a number. This will calculate both. Now we're gonna do all of the good one, because I think this one was, yeah, part 2 did everything of part 1, just didn't return the thing. Boop, there it is. There we go. So all of this is correct. We just want a valid output. So what we're going to do is say let output equals lovely string. And this is going to be ternary eyes. Output add. There we go. And then here it's going to be output add new line. Well, if all of this output add new line. New line. There we go. And finally, oh great, asynchronous. Did not need that. That was for the animation, which we have finished. Return both the, I guess I swapped these around. Number first for our strength, whatever. And strength second. So number first, then output. If we drop, well, if we keep solve 1 and solve 2, we'll just return accordingly. Turn, there we go. Keep the flow. Come here, you. Boop. Now we can turn Quokka back on, and 1 should be working. Cannot output. Great, I declared it below my call to ink. There it is. Boop, boop. How's 1 looking? 1 looks great. How's 2 looking? 2 looks terrified because there's no assertions anymore. Ah, gotta add that back in. Boop. Building this ASCII drawing will be fun. Open it. Still a promise, apparently. Fix that. Boop, boop. There we go. And hopefully there's some output I can yoink. Not really. I mean, here, there is some output. Nice. With the trailing. Oh, that's going to be fun to fix. We ain't out of the doghouse just yet. Paste. Guess we won't use this. We'll use boring strings. Yeah. Now this technically should pass. Oh, there's too many pluses. There we go. That technically passes, and look at that. Look, we got our lovely output. Is that P supposed to be filled in? Yeah, that makes sense. That's how an ASCII P would look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 2, 3, 4, 5, 26, 27, 28, 29, 30. Okay, yeah, it is 40 wide, so it's literally just being extra, ran an extra time. Just checking. Okay, so let's fix that part too, at least. To have an extra instruction? Nope. Who draws output? This one, which is the incrementation of a cycle. I could just literally get rid of it, like chop it off. But that don't feel right. But no one's gonna tell. No one will notice. I probably need to chop off 2 characters in that case. Yeah, double slice. Chop, chop. Just gotta get it right. Or you can slice and trim. Because the trim will get rid of it. There we go. It's good enough, folks. Good enough in my book. Lovely. Oh, look at that. Blah, blah, blah. Now that we have that working, real optimizations. So let's start getting this looking Good. So this part here, as we've done this before, for const command, and we don't even really need args, do we? Command. Guess technically so, but it's only one arg. Arg. This will be a number, so no need to do any int parsing. I love a good increment cycle. Again, this is a rough way of doing it, but it works. Yeah, I'm good for that. Now the actual incrementation of the cycle and strength calculation. So let's first declare these X, Y, output, and strengths. Yeah, those two can go there. And this is core, which is technically, what did they call it? Horizontal position. Horizontal position, there we go. If cycle and horizontal position 0, add that. Otherwise, add whatever cool pixel you want. We'll use blank spaces for prettiness. Just as I created that test. Boop. There we go. We love that. Okay, it's angry, but oh, the trim got rid of it. Yeah, so instead of dot trim, we need to slice to. Loving it. Hey, look how more readable that is. Okay, so if is 20. Technically, we want this to be here. So we can drop this strength check into here. So while it's this, if it equals, add it, then break until we get past the point we currently are. Not the best way, but it works. Probably a better math way. We ain't about to try that out. We can make this into a for loop, probably. Temp equals 20. Attempt less than or equal to cycle. Attempt plus equal 40. Easy for loopification. Love that. Then break whenever you do find one. Good. Get your own line because you're fancy. Yeah, that should be my optimization. Part 1 still works. Part 2 still works. Oh, 2022. There we go. Again, folks, this wasn't exactly a, it's basically a math juggling game, you know? So for the no ops, you increment the cycle, which first you draw a pixel based on whether they overlap with the drawing sprite. You increment the cycle, and then you check against the, if you want to add the current strength based on the cycle modulo 20 plus 40. And that logic goes into the two commands we have. The no op, which just moves forward, and the add x, which runs before and after the change. Now, I know this isn't technically right since I gotta slice that character off, but it's functionally right. Yeah, I know I started a little late today, but real laugh and all that. So I will commit this away. Yep. Hold on. Here we go. And we will not be doing a visualization for today, because real life and all. But tomorrow is Saturday, so got that stream there. we'll have some fun there, and probably as Advent comes around, fiddle around with the old visualizations, new ones, whole shebang. In the meantime, though, we will go and find. Hey, would you look at that? We got ourselves fellow 100 ever Omi fans. Let's go ahead and give them a nice, lovely raid. Again, fellow 100 ever, so feel free to show the love. They are currently doing. Oh, the bot is dead. Yeah. So they're currently doing their portfolio designing with GSAP. For those who don't know, it's a JavaScript framework for animations and stuff. So somewhat close to visualizations. Yeah, intelligence, let's go! Yeah, stream tomorrow, we'll have all that fun stuff then. And we'll do some Advent toward the end.